Now on to the bonus topic, where we're going to be talking about leading pedestrian intervals. This was a frequently asked question that's been coming up over the last few weeks. So we thought we'd tack it on to the existing three topics that we had before. And this is specific for the ring barrier controller. So for those of you that aren't familiar with leading pedestrian intervals, what this does is this is at a signal. You release the pedestrians first, so that way right turning vehicles or permissive left vehicles are waiting, and it's designed to increase the safety of the crosswalk itself. So if the pedestrian signal goes green at the same time as the as the protected right turn overlap or a permissive left turn, pedestrians haven't navigated into the crosswalk as fast as the vehicles are trying to cross over. And so it can impact not only the pedestrian level of service on that crosswalk, but the pedestrian safety as well, because drivers might be paying attention more to the signal. So what you do is you release the pedestrians first, so they are actually in the crosswalk and drivers can see them and are aware of them. So the key parameters here in a leading pedestrian interval in the VISM RBC, it's not there's not a specific parameter for a leading pedestrian interval. So we kind of have to tweak the RBC in a little bit using an overlap to allow for this timing. So the key here is that you have your parental signal group or your phase number that stores the default timing, such as your red and your green and your yellow timings. You have your pedestrian signal group associated with that parent phase. So in our image here, we see phase 12 as our parent phase, and then phase 102 as our pedestrian phase. And then we code in an overlap signal group that its only parent phase is, in this case, phase 12, and it has a delayed green of 5 seconds. So this would be the way that we hold back phase 12 for 5 seconds. And it will automatically release the pedestrian on time. So let's look at the parameters a little bit more detail. So when you code it in, configure the basic timing in the parent phase. In this case, I've replaced phase 12 or phase 2 with phase 12 because later on we'll be putting phase 2 onto the signal heads. So you configure the pedestrian timing in the column of the parent phase as you would normally. So you'll do the parent phase and the pedestrian phase as normal. You put it into the sequence as normal. And then you create its own overlap phase. And the key here is, aside from just creating the overlap phase and assigning a parent, you'll need to come into the table of contents on the left there and select 2 new parameters called delay green and delay enable. This will, sometimes people forget the delay enable part, but this is the key part where you are coding in the delay green is the amount of time that you want the LPI to be active for. So in this case, 5 seconds. We're holding back the vehicular phase for 5 seconds and letting the pedestrians have 5 seconds of walking. And in this case, we've coded it so that the walk timing is the same as the LPI timing. So that way, when the vehicular phase goes active, the pedestrian phase goes into flash don't walk, so that theoretically new pedestrians won't step out into traffic. Then you need to enable that phase. So make sure that you enable that phase by selecting the parent phase in the delay enabled section. Finally, on the signal head, you'll code it as an overlap phase. So this is why I switched phase 2 and 12. So typically up at the top in the basic section, you'd have 1, 2, 3, 4, 5, 6, 7, 8, and then you have an overlap phase 12. For clarity purposes, I switched those so that on the signal heads, when you are flagging which phase you want to be the vehicle phase, you are flagging phase 2 as opposed to the overlap phase, or you're flagging overlap phase 2 as opposed to the parent phase 12. And we'll see this in our example here. So let me jump into the example. So here we have a standard intersection with crosswalks on all approaches. Let me just turn off my background map a little bit. So in our signal controller, what we have is we have an LPI coded for phase 2. So what I'm going to do is I'm going to go to open up my signal controller, my RBC. I'm going to hit basic view. And this is just the basic timing. And this is really mostly all that you need to code this in. So here, let's say we wanted to code an LPI on phase 6. So phase 6 has a pedestrian phase. It has all of its basic timings. What we would do is we would go into the overlap section on the right here, and we enable delay green and delay enable. So that when I come down to my overlap section, I can see my overlap signal groups here. In this case, in our model, we already have an overlap for phase 6 because we have a protected right turn phase. So in that case, if you have a protected right turn phase with an overlap, then all you need to do is code in your delay here and your delay enable for that phase, for those phases. So you just highlight both of these phases so that they are delayed a certain amount. Now in this case, we only need to code in phase 6 because the pedestrian phase only goes with phase 6. So you don't need to delay phase 7 at all. So what this would do is phase 9 in this case would go active during, it would be green for phase 6 and phase 7, which is the northbound left turn phase. So it's active for both the northbound left and the eastbound through. And that's just the default overlap setting. But we've put a delay green on it, and we've delayed phase 6 in particular, so that way it holds phase 6 back by 5 seconds, allowing the pedestrians to go through. If we were going to, if this didn't already have an overlap phase, how I would code this is I would make the parent phase number 16, and then I would come down to the overlap and make, the overlap phase 6. That way it shows up on the signal controllers, or on the signal heads. So again, you have your parent phase all coded up with the basic timing, and then you have this delay green and delay enable. Click OK, click OK. On the signal heads themselves, for example, on this westbound through, if I double click on it and select the signal groups, we can see we have signal group 12, which is the basic signal group. And then we have the overlap signal group number 2 that we'll select. Now I've opened up the signal times table, and you can do that by right clicking on your signal controller and saying show signal times table. And I'm gonna run in test mode so that we can just run it without some vehicles to start. And we'll ignore the first cycle because it just kind of goes through everything there. So now we see the left turn's active, and then we saw that the pedestrian phases were green, and now that the parent phases are going green, the pedestrian phases have gone to clearance, and that's because we've timed that delay green equal to the flash don't walk phase. In our signal times table, we can see that right here. So this is, we can see it every cycle. So here's phase 12 right here, where phase 12 is starting on time with the pedestrian phase, but phase 2 is actually delayed by 5 seconds. So it's holding back phase 2 by 5 seconds. In this case, we're also holding back phase 9 by 5 seconds as well. And so that's how you code the lead pedestrian interval on the RBC.